This week on the show, we cover FreeBSD 12.1, which is here finally, a history of Unix before Berkeley, FreeBSD development setups of developers, HardenedBSD 2019 status report, the DNSSEC on OpenBSD's Unbound, and compiling RainbowCrack on OpenBSD, and more in this week's episode of BSD Now. BSD Now, episode 325, Cracking Rainbows, recorded for the 20th of November 2019. Hello, I'm your host, Benedikt Kreuzling.
And I'm Alan Jude.
And we are back with a great BSD Now episode filled with interesting news and stories, so we're getting right into it with the headlines, starting with FreeBSD 12.1 being released. Woohoo!
Yeah, quite a bit of good stuff in there. I think the biggest thing for a lot of us is it's the first version, a release version of FreeBSD that supports running the OpenZFS port. So if you want to try out the new updated version of ZFS, you can now just build it from ports. And I imagine once 12.0 is end of life in another 2 months or so, you'll be able to install it as a package even. Because 12.1 includes the required cryptographic support for the native ZFS encryption and so on. And so, yeah, if you just go under sysutils OpenZFS and install that port, you can try out the new version of ZFS starting with 12.1 release.
Yes, this is the new way the world will turn, at least in ZFS land. And so you will be wise to update to this and have the building blocks there for the future updates that are coming.
Mm-hmm.
But that's not the only thing they added. There were a bunch of changes in this. The highlights they list in the release announcement are that Bare SSL has been imported to the base system.
So that's specifically about upcoming support for secure boot related things. So OpenSSL is a little big, whereas Bare SSL is a little more designed for embedded type applications. And so it's being used for a combination of secure boot and Vera exec, basically being able to read signatures and check hashes on files so that you can say, we did secure boot to boot the EFI loader, and now the EFI loader is using Bare SSL to verify the hashes and signatures of every file it reads going forward, and eventually you get a secure boot chain all the way to the end.
Okay, that sounds good. Yeah. Small is beautiful, and with the history of OpenSSL security, we'll see that a different version might have less of that. Then there were updates to the whole compiler toolchain, Clang LLVM, LLD, LLDB, compiler RT utilities, and libc++ have been updated to version 8.0.1, and so that's in the base system.
Yep. Other interesting stuff in userland, MLX5 tool has been imported, which allows you to do firmware updates on Mellanox ConnectX 4, 5, and 6 cards. So if you're using their, 10, 25, 40, 50, 100, and more gigabit network cards, the tool to do the firmware updates is built into FreeBSD now. The swap-on tool now has a capital E flag, which or can be specified in your FS tab as trim once, so that when you first swap on the device, it'll trim it all so that it's empty. And then, you only need to do that once, but it means that when you mount the swap at the beginning, that you trim it all so that it doesn't have any leftover stuff and helps with performance on SSDs.
Yes, as more flash devices are becoming the mainstream, this is good to have.
And then the NVMe control and CAN control commands got some minor updates, and ZFS now has more support for some of the other flags, specifically when using the send subcommand for bookmarks. So you can use -nv to estimate the size of a send that starts with a bookmark. Normally with incremental replication in ZFS, you have a source snapshot and a destination snapshot, and you say send all the data in between those. The downside to this is you have to keep that old snapshot around, which means any data that existed when that snapshot was taken but has since been deleted is still taking up space on your machine. If you convert that snapshot into a bookmark, instead of keeping all the data older than that snapshot around, it just keeps the timestamp. So a bookmark literally takes a kilobyte of space. You still need a second snapshot, and you can basically send the difference between the point in time of that bookmark and the newer snapshot. But it allows you to do incremental replication without having to keep the old data that wouldn't be sent during that incremental snapshot or incremental send around. And some work was done on the ZFS command so that you can estimate the size of doing it with a bookmark like that, so that tools can give you a progress bar and all that kind of interesting stuff.
Or just estimating how long it would take to transfer that, or how much data is actually in the stream. Yeah, that's good to have. There is some updates to utilities. For example, FreeBSD update got 2 new subcommands, updates ready and show config, so that you can kind of estimate how much, or if there's updates ready, you just haven't installed them yet, or show config, that you can kind of know what kind of config changes you will have to do.
Then they have updates to the ICHWD driver to provide a watchdog on the Lewisburg and newer C620 Intel chipsets. The AMD SMN and AMD Temp driver has been updated to work with Ryzen 2 and the AMD 2990WX CPUs. The RTWN PCI driver has been updated for the Realtek 8188EE chipset for wireless. The crypto driver has been updated to print warnings if you use a deprecated algorithm, because those are algorithms that are likely going to be removed in 13. And so this way, the first time you use it, it will print a warning to your log file so that you might learn about those. The NVMe driver has been updated to support suspend and resume for PCI attachment, which is good news for my laptop, which has NVMe and suspend and resumes a lot. And this will prevent some of the timeout errors and so on. The CDCEEM driver has been added, which adds a support for the virtual USB network card provided by the ILO 5 HP servers. Thanks to HP Enterprise for sponsoring that work. And the Fuse driver has been overhauled and implemented a lot of extra features and so on, thanks to the FreeBSD Foundation for sponsoring that, and Alan Summers for doing the work.
Yep, that was part of the work and that is finished and now part of the release.
And the MPS and MPR drivers for the LSI HBAs have been updated with some stability fixes. Cam controls added some ATA power mode support so that you can power drives up and down and so on. Deprecation warnings have also been added to Gelly if you're using not recommended crypto algorithms. And the CAM subsystem has been updated to improve the AHCI enclosure management and SES interoperability, which gives you more data about your drives and so on. And the FreeBSD loader has been updated to allow booting from ZFS datasets that have the large dnode feature enabled, and to support the Delphix device removal feature flag. So you'll be able to boot pools with those new ZFS features.
Good. Yeah. Being future-proof in this way, so you can run the latest pools with the latest features enabled. Networking got some stuff. The IPFW utility has been updated to fix showing headers outside of the all when executing IPFW table list.
Yeah, a bunch of other minor things in there.
Yeah. There's also stuff they removed. So it's not just new features all the time. They also deprecated some things that will not be around for long. So, for example, there is the CTM utility that's been marked as deprecated and has been removed in FreeBSD 13, or when that will come out, as well as the timed utility. This is also marked as deprecated. So in case you're still using those, you might consider the alternatives in either.
Because both of those are pretty terrible.
Yeah.
Also, there's a big note, heads up, if you're when you're considering upgrading to FreeBSD 13 when that comes out next year, or maybe even the year after. Anyway, the default CPU type for all i386 architecture machines will change from 486 to 686. So you're not going to run FreeBSD 13 on your 486. So that means by default, binaries produced will require a 686 class CPU, including but not limited to binaries provided by the FreeBSD release engineering team, and so on. FreeBSD 13 will continue to support older CPUs. However, users that need that functionality will have to build their own release. As the primary use of 486 and 586 CPUs is generally in the heavily embedded market, the general end user impact is expected to be minimal, as new hardware with these CPU types has long faded, and much of the deployed base of such systems is nearly at retirement age. I don't have anything that old still running.
Yeah.
They say there are several factors taken into account for this change. For example, the i486 does not have support for 64-bit atomic operations, meaning that if you're trying to add some number to a 64-bit number, it actually is two separate operations, which means that it's not safe to do concurrently with others. And while that can be emulated in the kernel, they cannot be emulated in userland. Additionally, 32-bit AMD 64 libraries have been i686 since their inception. So even if you're still using, if you think you're still using this with like lib32, that's been 686 since it was invented almost 20 years ago.
Yeah, it's been a while.
With the majority of 32-bit testing being done by developers using lib32 on 64-bit hardware, or with the compat FreeBSD 32 option in the kernel, this change ensures better coverage and user experience. It also aligns with what the majority of Linux distributions have been doing, although most of them have even dropped 32-bit altogether.
Yeah.
This change doesn't affect 12.x. We're not going to, stop working on a CPU that worked in 12.0 is not going to stop working in 12.1. It's just a heads up that in 13, if you are building an embedded appliance that uses a 486 class CPU, that you're going to have to compile it yourself rather than use the releases, which you're probably doing already.
Yeah. Don't say we didn't warn you. Check out also the errata notice for any late-breaking changes.
Those are all the changes that happen between 12.0 and 12.1.
Sure, yeah.
Okay, so next up, we have a history of Unix before Berkeley, the Unix evolution from 1975 to 1984.
Yep.
So this article traces some of the intermediate history of the Unix operating system from the mid-1970s to the early 80s. It is slightly updated from an article that appeared as The Evolution of Unix from 1974 to the present, part 1, in Microsystems magazine in November 1984, when present meant 1984. It is intended to be part 1 of 3. Unfortunately, that issue was also the last issue of Microsystems magazine. So this article discusses Research Unix v6, 7, and 8 and tells the tale of many programs and subsystems that are today part of FreeBSD or System 5. Subsequently, articles were planned to discuss in more detail the history of Berkeley Unix, System 5, and the commercial Unixes. We have not written those other articles, and this article was reprinted in Daemon News in 1999 in hopes that those who had written histories of other parts of the system would come forward and provide those other pieces. So, introduction. Nobody needs to be told that Unix is popular today. In this article, we will show you a little of where it was yesterday and over the past decades. And without meaning in the least to minimize the incredible contributions of Ken Thomas and Dennis Ritchie, we will bring to light many of the others who worked on early versions and try to show where some of those key ideas came from and how they got into the Unix that we have today. Our title says we are talking about Unix evolution. Evolution means different things to different people. We use the term loosely to describe change over time among many different Unix variants in both inside and outside of Bell Labs. Ideas, code, and useful programs seem to have made their way back and forth like mutant genes along all of the many Unixes living in the phone company over the decades in question. Mm-hmm. So part 1 looks at some of the major components of the current, being 1984, Unix system, the text formatting tools, the compilers, and the program development tools, and so on. Most of the work described in part 1 took place at Research, a part of Bell Laboratories, now AT&T Bell Labs, and then as now just called the Labs, and the ancestral home of Unix. It planned, but didn't actually deliver. Later parts, we would have looked at some of the myriad versions of Unix where there are far more than one might suspect. This includes a look at Columbus and USG and at Berkeley Unix. You'll begin to get a glimpse inside the history of major streams of development as the system changes during time. I'm not going to read this whole thing because that would take all afternoon, but they talk about where some of the basic sources came from. I have a note here. Since we can't say everything about Unix in this article, we'll give some pointers to those who want to read more. Full acknowledgements can be found at the tail end of each installment, but some basic sources must be mentioned. It is a truism that the final source of information about Unix is Unix itself. And this, of course, requires you to have a source license, or did back then, not anymore. And to get a source license, you must sign in blood that you will not divulge the source code in any way, shape, or form. So in preparing this article, we stay clear of looking at source code, but there are times when you do, when you want to do so, not so much to find out how some feature evolved, but as to see how it actually works. And then they note, since this was written in 1984, the John Lyons book Commentary on Unix 6th edition has been released. This contains the complete source code of the Unix kernel, as well as the 6th edition, along with detailed notes on how it works. We were saddened to note the passing of John Lyons in late 1998. And finally, in 2002, a decade too late, the source code for V7 Unix itself was released by Caldera, its final owner. For much more modern source code, the source of the free Berkeley Unix derivatives, such as OpenBSD and FreeBSD, is freely available.
Okay.
And it talks about a bunch of different things, including, and the manuals are sometimes derided for their bugs section.
Yeah.
At the bottom of each man page telling you about known problems. This is a place where authors of the program list is sign limitations. One critic said of this policy, if they know about the bugs, why don't they fix them? Well, oftentimes we didn't have that much time.
Do I have to do everything? Someone else could pick those up.
So Richie added, our habit of trying to document bugs and limitations visibly was enormously useful to the system. As we put out each edition, the presence of these sections shamed us into fixing innumerable things rather than exhibiting them in public. I remember clearly adding or editing many of these sections, then saying to myself, I can't write this, and fixing the code instead.
Okay, well, that's at least honest. I personally like the little further down section 4.7 about awk. So it seems to be new at that point. But it's nice that they write here the names of the three authors put together is the most pronounceable way. Aho, Weinberger, and Kernighan. And so what they did when they couldn't think of a more imaginative name for a wonderful program they devised, and they say that Kernighan and Pike's book remarks that naming a language after its authors also shows a certain poverty of imagination. So they say that awk is not at all awkward. It's a great simplification, and they bring even a little example, like the classical AWK-F: print $1 for etc pass WD to show all the user accounts in the printer names in etc pass WD. This is like the classic beginner AWK one-liner. But yeah, check out the full article. It has a bunch of interesting things from a historical perspective and from where Unix came from. And how are things currently?
And then they have another one that I had never heard of before here, called S. That's in the letter S. Finally, we cannot overlook an interesting, quote, application language from research, S, an interactive environment for data analysis and graphics. The title of the 1984 book by Richard Becker and John Chambers put it succinctly, and I put it as follows. The S package is to conventional mainframe statistics packages as the Unix shell is to batch job control languages. It provides interactive, exploratory statistics, interactive and offline graphics, and data modeling and time series manipulation. The S language was developed at research. The first public release was in 1981, which was for V7 and 32V. There were several interim releases. The next major release was early in 1984. This release was accompanied by a change in license and an order of magnitude cost increase for non-educational users as part of a swing to commercialize it by AT&T. The only remotely similar product that I know of in all of computerdom is APL and Speakeasy. APL was first implemented on IBM systems. At least one version that was developed. And Speakeasy similarly arose on IBM hardware. A subset version called Speakeasy was developed at Purdue University.
Oh.
Speakeasy was developed sometime before S, but in quite different circles of influence. It appears to be that there's no cross-pollination between the two, although many of the ideas are similar. S uses the YAC interpreter to interpret its grammar, and YAC specification applies to the CACM paper that came out in 1984. I wonder if R is related to that.
I'm fairly sure it is, yeah.
But they just went the other way in the alphabet. Instead of, B begat C begat D, we now have S that begat R.
Didn't want to call it T because maybe that was taken somehow, or we'll never know. But yeah, since I didn't know that history from that.
It'd be interesting to do something like this, but temporaneously, like look at the difference in Unix between, say, 2000 and now, and say, what did we invent in the early 2000s that actually changed Unix significantly?
Yeah, like what had enough impact to still be around today and still being developed today. I mean, some tools are like as good as they are and don't get, here and there a couple of bug fixes, but they don't get whole new features. Whereas other tools get heavy updates because they're kind of, dependent on architectures or are so tightly integrated with the system that it has to evolve with the system, whereas some other things can evolve a little bit slower, if at all. So yeah, it's interesting to watch Unix evolve in this way.
Yep.
The next thing is something more for the practical side of things, because we have an article here showing my FreeBSD development setup over at theadventurist.me.
Yeah, so this is Tom Jones's blog.
Even better. Ha! Excellent. Greetings to Scotland. So he writes, I do my FreeBSD development using Git, Tmux, Vim, and Cscope. He keeps a FreeBSD fork on his GitHub, listed in the article. And on his fork, he has the FreeBSD/FreeBSD repo set as an upstream. So he does git remote-v, so you can see the origins and the upstream.
Yeah, so the origin is his clone, and upstream is the official clone.
Mm-hmm. And he has a separate article for configuring a remote for a fork.
Well, it's an official GitHub article.
Get to started if you haven't looked at GitHub or Git too much. He does all his work on branches using work trees, keeping the master branch clean. Periodically, he syncs the master branch with the FreeBSD upstream, and he shows us the commands to do that. Basically switching to the git checkout, I guess. Then does a git checkout master, then a git fetch upstream, then a git merge upstream/master, and then git push to actually make the changes appear for everyone. Then he has a development setup based on Ian Lepore's ARM setup, documented on the FreeBSD wiki page. He linked as well. And a FreeBSD/dev directory in his code directory. In there, he keeps a copy of FreeBSD in FreeBSD-git and OBJ directory for build output and projects directory for in-progress code. So here's a little tree output of his directory structure. He uses Git work trees for ongoing projects. Git work trees allow you to have a shallow file system copy of a Git branch in a directory. When starting a new project, he does something like cd code/FreeBSD/dev, FreeBSD-git, then Git work tree, add thj/new development, whatever it might be, and then /projects, new development master, and then cd ..projects, new development.
Yeah, so basically makes an extra copy of the FreeBSD checkout at that directory, but it's all still tied to the same Git clone. So it lets you have each of your separate projects or patches or whatever in a separate directory with a clean checkout, so you don't end up with two patches getting mixed together, but without having to have the whole Git checkout multiple times.
Yes, so you can keep those separate and clean. And once he has the work tree set up, he launches a Tmux session in the projects directory. So each random idea or itch he has is there. If there is enough there, he ends up with a project work tree and a Tmux session. Because Tmux allows him to have many windows in a session. He has a serious Tmux problem. Well, he's not alone in that. I'm not there yet, but others, I've seen a lot of Tmux sessions running. So right now, he has 11 sessions with 42 windows across them. That's pretty much how my browser looks like. This is a good indicator of his focus level. Well, you start doing here and there a little bit of work, and suddenly something is advancing. I do FreeBSD development with Cscope and Vim, he writes. With Tmux splits, I normally have an open file and I use other Cscope instances in Tmux windows to search for things I need in the tree. I do testing in a Beehive VM and leave the serial port in a Tmux window somewhere. I follow the setup in the FreeBSD handbook with a link there as well, and back each VM with a ZFS dataset. I use FreeBSD kernel builds using a command line that's a bit longer.
Well, basically, he sets his object directory to be the obj subdirectory of his git checkout or whatever. Builds the kernel with all the CPUs he has with the flag kernfast and install kernel, and then he also does capital D no root, so that it doesn't need root to do it, and sets the destination directory to his dester.
Yes. It then ships the kernels to the test VM with SCP. And John Baldwin has a nicer method using the Beehive loader, but he's yet to try that. And when changes are maturing enough, he creates a review for them using the Arcanist, and Manu over there has a good article on doing that as well. Also, Tom Jones has an interesting keyboard, at least at work, that I saw when I was in Aberdeen this April. So that keyboard doesn't have any description on it, or no keys that have like a
markings.
Yeah, no markings, no characters, but it's built up in certain levels, so you can switch levels, like in a 3D chess probably. In Star Trek, you probably have seen that, and so he can like switch between different input levels. It's very sophisticated, and he's productive with that, but I couldn't like find the Vim exit for the life of me in this keyboard. So that is a pretty separate article here.
Mariusz Zaborski has an article on his blog similar to John Baldwin's method for using Beehive Loader. I used it recently to do something like that, where I have basically I'm doing NFS root for a Beehive. So the Beehive boots up in the loader, gets its IP address, and mounts a directory from the host machine via NFS as the root directory, so that I can just compile a new kernel and install it from the host, which has 40 CPUs, into the Beehive that has 4. It's a lot faster than either compiling it and copying it in, or trying to compile it inside the VM or whatever. Very handy, because I now have like 4 or 5 different VMs running, testing different ZFS things currently.
Yeah, and it's kind of interesting to see what these developers are using as tools, and maybe there's a tool that haven't looked at or didn't know before, and so it's a fairly nice way of finding new things, how these people work, switching contexts sometimes, and in general, what makes these people productive. Check out his other blog posts, and maybe something is in there for you that's interesting enough. So thanks, Tom, for writing that up.
So next up, we have updated version of OpenSense 19.7.6. They say, hello from Suricon. As we are experiencing the Suricata community firsthand over in Amsterdam, we thought it would be nice to release the new version of OpenSense a bit early to include Suricata 5.0. That means that later this November, we will release version 5 to the production version as we finish up tweaking the integration, and maybe pick up 5.0.1 if that's available at the time. Also, major change is LDAP TLS connectivity is now integrated into the System Trust Store, which ensures that all required root and intermediate certificates will be seen by the connection setup when they have been added to the authority section. The same is true for trusting self-signed certificates. On top of this, IPsec now supports public key authentication as contributed by Pascal Mathis. And then, a bunch of other fixes, including fixing a PHP core loop failing in the tunables overview, and allow P12 format exports if the password confirmation matches, and making the PCAP downloads be a binary file stream, so setting the right header on that.
Oh, interesting.
And then, various plugins being updated, including newer versions of Acme Client, Bind, Nginx, RelayD, and updated ports, including the CA root NSS trust store, new versions of PHP, Python, and sudo.
A little refresh here and there. Okay, we also have news from the HardenedBSD project. They have put out a November 2019 status report. Has been submitted by Sean Webb here, and Sean writes, "We at HardenedBSD have a lot of news to share. On November 5th, 2019, Oliver Pinter resigned amicably from the project. All of us at HardenedBSD owe Oliver our gratitude and appreciation. This humble project, named by Oliver, was born out of his thesis work and the collaboration with Sean Webb. Oliver created the HardenedBSD repo on GitHub on April 2013, and the HardenedBSD Foundation was formed 5 years later to carry on this great work. So as he rebuilds the HardenedBSD build infrastructure, he will be performing the following user-facing changes. The first one they list here is the HardenedBSD stable Git repo will be archived off. HardenedBSD will still utilize the HardenedBSD playground.git repo for collaboration with third parties and extremely experimental code. So that's the news here. The second is we are slowly transitioning to being fully self-hosted. It is my goal to complete the transition on or before December 31st, 2019, just before the year changes. Yeah, okay. So they start something new in January, very first. Yeah. So this means we will stop using GitHub altogether. Okay, so people don't find updates there anymore. So stay tuned for more information on the HardenedBSD website.
Yeah, I don't know if they would go to a read-only mirror there like FreeBSD currently has or what.
Could be, yeah, and they run their own thing. Then the third thing is that downgrading 11 stable to community support. Given all that it's on his plate, he can only maintain 13 current and 12 stable right now. Yeah, there's only so many things you can do. Therefore, if the community wants 11 stable support, the community will need to provide it. Okay, that's only fair. Git commits performed by our infrastructure will be signed by our dev key. Think our auto-sync scripts that run every 6 hours.
So I think those are the ones that pull in commits from FreeBSD.
Yeah, okay, so that's also signed. Then he has a couple of random bits of other news. He's currently working on getting the sync scripts running on the new infrastructure. He's not too far off, he writes, but I will likely take around another week to re-enable the auto-sync. Okay. Our AMD64 package builder is experiencing stability issues. Due to some upstream network changes, some packages are failing to sync. Our package repos for 13 current and 12 stable are woefully out of date. I'm actively working on this as time permits. I have no ETA or updated repos. So Ben LaMonica from the HardenedBSD Foundation is looking into LDAP/Kerberos integration for our infrastructure. We are looking to unify everything in order to enable finer-grained control of our infrastructure along with easier centralized management. Okay, then he writes that the new build scripts are coming along very nicely. One last change he needs to make is to skip the build if no commit happened between the last build and the freshly started one. Yeah, no need to work if no new work is pending. With a separate commit, the build scripts now track the revision of the source tree. This can be used to check whether there have been any updates since the last successful build. Then he has a couple of things about ports and packages. By the end of November, I hope to turn the build scripts into a port/package. It is my goal to be able to package install our entire infrastructure. Given the complete rebuild of our infrastructure, we will no longer use the domain installer.hardenedbsd.org. Our primary mirror is now ci-01.nyi-hardenedbsd.org. I will update our website to reflect those changes. And to our mirror operators, due to the complete rebuild of our infrastructure, they have not been re-enabled rsync on the primary mirror. They will be thinking of a different method to authenticate than before. I will provide example steps to convert your existing configuration to the new one. He's excruciatingly behind with the administrative side of HardenedBSD. If you have donated and I have not reached out to you, please forgive my tardiness. Know that you are not forgotten and I will get to you soon. HardenedBSD and especially me appreciate every contribution, no matter the form it comes from, like code, money, advocacy, etc. Lastly, Sean likes to thank everyone for their patience. He knows his downtime has been extensive. He's grateful to have the opportunity to serve the community in his spare time, and thanks for providing him the opportunity to serve us, or you. Okay, that's the news from HardenedBSD.
Now we're over to OpenBSD, where DNSSEC is enabled by default in their Unbound configuration in base. So this will enable DNSSEC validation in Unbound by default in the unbound.conf that ships in etc. Re-enable the val log level 2, so that when sites have misconfigured DNSSEC, the sysadmin has some idea what's going on in the logs. And aggressive NSEC equals yes. If we are using DNSSEC anyway, we might as well get the benefits. They were both enabled last time DNSSEC was enabled in the sample unbound.conf. And then finally, perform constraint validation against 9.9.9.9 and the IPv6 address 2620:FE::FE, which avoids DNS lookups entirely. But yes, this HTTPS is correctly validated. Long discussions with Otto Florian and the people over at Quad 9.
Okay.
Previously, they had attempted to have DNSSEC on by default late in 2018, but it ended up being reverted because of difficulties bootstrapping machines that had when their clocks were wrong. But they feel that problem is overcome now.
Okay, good. Second time's the charm.
Yes, because you get the obvious catch-22 of use NTP to set your clock, but to find the NTP server, you need to look up the DNS name. To resolve the DNS name with DNSSEC, your clock must be more or less right.
Yeah.
Yeah.
Difficult, to get out of this conundrum. But yeah, they solved it, and you can now enjoy that in your Unbound. And now we have a little bit of a tutorial for you for how to install software. How to install shopware with Nginx and Let's Encrypt on FreeBSD 12.
Yeah, so shopware is basically an online e-commerce portal tool thing.
So they list, of course, the basic minimum requirements. So you need a Unix operating system, basically, with Nginx or Apache 2.x with mod rewrite. PHP 5.6.4 or higher with a couple of extensions.
Specifically, they say PHP 7.1 or above is strongly recommended since, 5.6 is not supported anymore.
They also want you to have, they're running this on MySQL. So, of course, you need the MySQL connectivity extensions as well as MySQL itself. And the possibility to set up cron jobs. So if you're somewhere on a hired machine that you cannot have full administrative access to, so you need to be able to have that. And minimum 4 GB available of hard disk space, shouldn't be a problem nowadays. And the IonCube loader version 5.0.0 or higher.
Which is basically a DRM thing for PHP.
Okay. So after this has been all set, you have basically here, they start here the prerequisites with FreeBSD 12 in this case, but I'm sure it will also run on other systems, but this is for FreeBSD, so we cover it. A non-root user with sudo privileges, yes, don't work as root, and if you don't need to, so use this. They will be using the domain name example.com in this tutorial. Of course, you can replace that with your own. First, you check your FreeBSD version. Yes, it's this should be actually FreeBSD-version, not uname-ro, but yeah, it will give you the same. You set up the time zone. Yeah, these are just some basic system setup stuff you do or have probably done.
Highly recommend you always set your server time zone to UTC.
Computers run on UTC. End of story. Check for FreeBSD updates in case there are some pending security things or some errata notices. So these can be installed. Do also the package update and package upgrade -ydance, and then you get some basic updates to your packages. They also recommend to install sudo, vim, unzip, wget, bash, and socat. Personal preferences sometimes. Then you install the PHP extensions. That's a big sudo package install PHP stuff. Then figure out the PHP compiled with modules. You can run PHP-m. This will list all your modules. And check the PHP version with PHP-version. Okay, yes, is 7.2. All right, then you start enabling PHP FPM by using sysrc. So you do sysrc PHP_FPM_enable equals yes, and start that service right away. So it's service PHP FPM start, all with sudo in front. Next, the install of IonCube Loader. This is optional, they list here, but we might as well do this to have a little bit more comfort this way. So you go to temp, you wget something from a URL and untar that.
Yeah, so basically download the IonCube for FreeBSD from their IonCube website and extract it and put it into the PHP library directory, which they have the command php-i pipe grep extension dir to find where that is on your system, because it will be different depending on the version of PHP you're using. And then you have to load the extension by adding it to php.ini and then restarting PHP FPM.
Yep. Next up comes the not mandatory, definitely necessary MariaDB installation and create a database for shopware. So it's installing the client and the server for MariaDB, then checking the MySQL version, starting the services with another service MySQL start, where you have previously done a sysrc MySQL_enable equals yes. And then you start MySQL_secure installation. It will run you through a couple of questions to make this installation a bit more secure than the default. And then you set, of course, your root password for the MySQL user and create a database and flush privileges. That's fairly straightforward for all database usage. Then you exit out of the MySQL shell, and then this step is done. Followed by step 4, install the Acme client and obtain Let's Encrypt certificates. This is also optional, but if you want to have SSL, and I can't think why you won't have that, get this, because Acme and the Let's Encrypt folks make it very easy to refresh those certificates and give you a good experience doing that. The next step after this is, of course, Nginx. Without a web server, you can't do much. So you install Nginx here using package install. Then you do another sysrc nginx_enable, start Nginx, and do a little bit of configuration. They have a separate config file, shopware.conf, where you basically define where the files are located that make up the shopware software, and make some location rewrites and some PHP extension stuff.
Yeah, basically say if the file ends in .php, then you need to connect via fastCGI to the PHP FPM process to have it run the PHP code for you.
Exactly. And then you check whether your configuration is correct before you restart the Nginx server using Nginx-T, which will check the config for any typos or logical errors.
Service Nginx reload will do that for you.
Oh, good.
Because since if the config is bad, reload or restart won't succeed. So you can skip the test step because the service command will do it for you and print out the error instead of reloading, saying, hey, this is broken. Go fix it.
Yeah. Your website is down for now. Okay, yeah, so this is good that they did that already. And then you install the actual shopware with the, you create a directory for it or a data set, like we people used to do. And then you navigate to the document root directory and then do another download using wget from the releases.shopware.com website and get the latest release, unzip that and release or remove the shopware zip after you did that. And then you change the ownership to the www user and group. Change the PHP ini to do what? Increase the memory limit to 256 megabytes and the upload max file size to 6 megabytes. This is basically what it needs to run smoothly.
Yeah, and so that you can upload large enough pictures of your products or whatever. Then
you give it PHP FPM reload. And then you browse to the URL that you set up, and there goes the setup steps are done in the browser now, and there you have your little shopware. Fairly straightforward, and some of the steps are basically the same for other web type software, CMSs, or whatever you have. So you can either reuse those or just be inspired by those. Cool. That's a nice way of starting your shopware installation. So now we have something that's also on the how-to side of things, how to compile RainbowCrack on OpenBSD.
Yeah, so rainbow tables aren't something I've thought about that much recently. But yes, Project RainbowCrack was originally written to allow you to use graphics cards to generate rainbow tables more quickly. For those who don't know, a rainbow table is a way of using a pre-computed set of hashes to crack hashes faster. The idea is that by making the time to space trade-off, if you're willing to download this 60 gigabyte file and use it, you'll be able to crack through a range of hashes a lot more quickly because it has pre-computed a bunch of the values so that you can do the hashing more quickly. Although these were mostly targeted at things like MD5 and SHA-1. The original tables you could download never included SHA-256 or SHA-512, although theoretically there's nothing stopping you from making rainbow tables of those. They would just be much larger because they're bigger hashes.
Much more time needed.
But the RainbowCrack website itself is mostly talking about old versions of Linux and Windows XP. And it looks like, most of this code was from the early 2000s, or maybe, the last time one of the web pages was updated appears to be August 2007. In fact, actually, if you might want to watch it, one of the URLs here, the antsite.com one, redirects to some kind of spam page. So you probably don't actually want to click on that link. The domain's been hijacked in the meantime or something. But the person who posted here at cromwellinternational.com has a patch for the one of the files for RainbowCrack 1.2 that makes it compile properly on OpenBSD.
Oh.
So if you would like to still use it, you can do so under OpenBSD now. Because it looks like it probably won't compile on a modern Linux either, just because so much has changed in the last 15 years. While doing a little research on it, just because I was curious about rainbow tables and so on, the OftCrack, or I don't know how you pronounce it, was it OPH?
Open password something.
Yeah, OPH crack is more modern and has a release as of last year, but it seems to be focused almost exclusively on cracking Windows passwords. It has support for the older Windows XP, Vista style LM hashes, but also the newer like Windows 7, 8, and 10 password hashes.
So they focus on that operating system. Okay. We'll leave it at that. Of course, we only use this software to check whether our own passwords are secure and not, gain access where we shouldn't.
Well, basically you'd have to steal the password file from somewhere first.
Yes.
In order to run a rainbow table on it.
To compare.
And this is why it's important that, the master.password file that we use on all the BSDs uses a salted hash. So instead of just the MD5 of your password, in the olden days when we used MD5, instead of the MD5 of your password, it was the MD5 of your password and this random salt string, MD5'd 100 times to make it even slower. But then we update it, and we have things like SHA-512 crypt and bcrypt. These do more rounds. I think SHA-512 crypt defaults to 10,000 rounds and a bigger salt, and bcrypt does a power of 2 number of rounds. Default was 4, usually use about 10 now. So that would be 2 to the power of 10. It would be just over 1 million rounds of the algorithm. And then you have the big fat salt, and usually the salt get mixed in a little more randomly rather than just all at once. But so if you think about a rainbow table, we took every word in the dictionary and we hashed it so that when we see your password hash, we can just look it up in this table and it'll be faster. But if we've added 8 characters or 10 or 20 characters of random gibberish in front of your password, you'd have to have a rainbow table that was every dictionary word preceded by 8 or 10 or 20 characters of randomness each. And then suddenly the rainbow table is petabytes large and it's not effective to be able to search it.
Yeah, not nowadays, yeah.
And that's why it's important that when storing passwords, you use a proper password hashing algorithm that has protection against things like rainbow tables.
We should get right into the feedback and questions section. Not before mentioning that you should continue to send us questions and feedback to the show. Otherwise, this will be a very empty section with nothing in it. This is feedback at bsdnow.tv, where you send your messages, show ideas, topics, feedback, or constructive criticism. We all read it. We're a bit slow sometimes to reply, but we'll either cover it in the next episode or we'll definitely have some kind of answer for you. Okay, so the first one this week is Reese with an amateur radio info. It's a short message, but nevertheless important. Reese writes, "Hello, thanks for mentioning HamBSD and KA9Q-Unix on the last couple shows. I have been into BSD and BSD Now for years and just got my radio license last year. Oh, great. I'm glad to pair these two interests together." Hey, wow. Yeah. We never know what kind of things people are interested in. And see, this is a good combination of two hobbies.
Yeah. I think there was a recent post by Adrian about some more radio stuff. We'll have to dig that up for a future episode.
Yep. That seems to be a vibrant community here. So, yeah, definitely use that. Thanks for that feedback, Reese. Next is Chris with VPN question. Chris writes, "Hi guys, thanks for continuing to do the podcast." Oh yes, at your service. So my question is about routing some jail traffic through a VPN. I have a machine with 12.0 release installed. I use IOCage to create all my jails. I have some jails that I would like to communicate with the internet via a VPN only. There's other traffic on the same box that I don't want going through the VPN. There's a non-managed switch between the machine I want to do this on and the router. My initial idea is to create a VNet jail that is running the VPN client, like OpenVPN, and have it act as a router for the jails that I want to use the VPN. And on the right track? Oh, am I on the right track? If so, what does the network inside the VPN jail need to look like? I know there will be one VNet interface plus a tunnel for the VPN interface. How do I create the second interface, the one on the other jails will connect to, What does the network for the jails connect to the VPN jail need to look like? Thanks.
Yeah, there's a couple different ways to do this. So I've recently created a VPN jail using the vimage stuff. I'm using WireGuard rather than OpenVPN, but same idea. So the vimage jail has an ePair interface. So there's one end of the ePair is on the host, and one end is in the jail. Then we create the WireGuard interfaces where WireGuard gets the internet out over the ePair interface, but the VPN endpoints are inside that VPN jail. Depends how you want to do this. The easiest way might be just to have the VPN client run on the host and then just have an alternate routing table or a FIB, forward information base, used for the jails that you want to use the VPN, and they will default to using the VPN and the other stuff won't. But that doesn't prevent something in one of the other jails from trying to talk to the VPN, which depends how paranoid you are, whether you're worried about that. Otherwise, you might have to have multiple ePairs or something. You might almost have to do each of the jails which you want to use the VPN will need to be a vimage jail. And then you'll take the host end of the ePairs of all of those jails and bridge them with a second ePair that goes to the VPN jail. So that would give you one broadcast domain, basically, one bridge device that spans all of the jails that need the VPN and the VPN. And then the primary ePair in the VPN jail will be the one that goes out to the internet and lets the VPN do whatever. That would work. There are many different ways to skin this cat. It really depends what your requirements are and how much work you want to do. And it might also just depend on how the limitations of your jail manager end up interfering with things. I don't have much experience with IOCage. For help with this type of thing, I'd recommend the FreeBSD Mastery Jails book. It's going to have as much information as you're going to find anywhere about this type of thing and how to do it.
Yeah, especially when you're using IOCage.
Beyond that, it's mostly basic networking concepts. It's just realizing that, basically you would use an extra bridge interface on your machine as a virtual switch.
Or maybe someone else has written this up on a blog post somewhere and we haven't found it yet. Then definitely our other listeners should send this to feedback@bsdnow.tv if you have done this yourself or know someone who did that and they have a write-up maybe, then we can cover it in a future episode or as a follow-up to this question. Because it seems like this is what people want to have. It's not a very obscure thing that will not be useful. It definitely will be useful. But yeah, thanks, Chris, for your feedback, and hopefully we'll have someone to answer you with like a concrete setup. So, whereas Chris was asking about VPN, Malcolm, who is next, has a question about NAT. Malcolm writes, I run Beehive VMs on my laptop, and in order to connect them to the internet, I NAT with PF. My rules look like, so NAT on VLAN 0, WLAN 0, that is, from 127.0.0.0/8 to any point to WLAN 0, and then NAT on WLAN 0 from 10.123.0/24 to exclamation mark 10.10.123.0/24.
So basically, if the 10.10 subnet is trying to go anywhere other than to that same subnet, then NAT it.
Yeah. Okay, so these are the rules. Sometimes I plug my laptop in, though, and the device is now UE0. Is there a way to allow PF to automatically switch which interface it uses rather than manually reconfigure PF? I think that is a job for like a bridge or like wired and wireless as a separate interface, and it knows which one is active and will route that through.
Oh, like a lag?
Yeah, that one.
Probably you have two major options. I think the main one would be, instead of putting WLAN 0, you use a variable that is somewhere else set to WLAN 0. Then you could use devd interface in FreeBSD to detect when UE0 goes up, in which case you would change that variable to say UE0, and then when it goes down, you would change it back to WLAN 0.
That's also good.
And so you could have it basically automatically change between two config files or change that variable with awk or set or something automatically when UE0 is up, and then change it back when it's down. That would probably be the easiest way. The problem with lags is that it never actually works 100%.
Oh, right.
But yes, you can create a link aggregation group, or LAG, LAGG, with those two interfaces. It only works with some wireless interfaces, though, because the MTU on wireless is different and can't be changed, and you can't change their MAC address, and so on and so on.
Okay, so that's the limit there. If you want to know more about devd, there is the FreeBSD Mastery Specialty File Systems by Michael W. Lucas, which he had to write to actually write the Jails book, and that explains how the devfs rule set works and how the config file is set up. So you can give it a short read, and then you or look at the man page. There's also information in there on devfs. Yeah, that's better. I didn't know about that limitation in lag, but yeah, both should basically get you where you want to be. Yeah, so thanks for that question, Malcolm. And that pretty much wraps up this week's episode. Thanks for listening in, and keep up giving us feedback at bsdnow.tv, and then we'll have future episodes for you.